Welcome back. Today we are going to really start the generic collection classes for which I'm quite sure that you must have been waiting for some time. So here you go. So before we take the first of the classes, generic classes, that is the listy class, we'll get back to some concepts building. So now the collection generic classes were added to the version 2.0 of C# language, and the most common use of generics is to create collection classes known as generic collection classes. And the generic collection classes use system.collections.generic namespace. And generics introduced to the .NET framework the concept of type parameters. Type parameters, or T, in general within a pair of angular braces, T is the type parameters. Type parameters make it possible to design classes and methods that differ the specification of one or more types until they are declared and instantiated by client code. By using a generic type parameters T, we can write a single class. Remember the word single class that other client code can use without incurring the risk or cost of boxing operations. Okay, so we have seen boxing, unboxing in array list and hash table classes, but we will completely get rid of it besides writing type safe code or strongly typed in other words, and we'll see in the next slide. Okay, so there is an example of a generic type T. Now what this does is, it creates a public class generic list T, and it creates a method, public method add, which returns null, and it takes an input of type T. Now this type T can substitute for an int, it could substitute for a string, it could substitute for any data type or any user defined types like any classes that you build. We'll soon see ample of examples to substantiate what I'm talking right now. So in this public method, all I want to do is to put a printout statement that parameter type is of type T dot to string. So here I think our reflection studies come handy because I'm using the type of operator to find the type of the class or the object instance, and value equals within pair of curly braces the input. Okay, so whatever input is passed to the add method is written over there, and it is simple. There is a test generic list class which has a private class, example class, which has nothing, it's an empty class, and in the main method, which is the test method, I have instantiated an instance of generic list with an integer. See, as I just said that T can be substituted for any data type, primitive data type, or any user defined data. Okay, so whatever you can imagine, you can substitute T for that data type. Okay, so list1 is an instance is equal to new generic list int with a pair of circular braces and list1.add1, list1.add2, because these are of type integer. Okay, 1 and 2. Similarly, you have got generic list string list2. Now this here, see, the difference between here and here is that int is now substituted with string, and we still use that generic list class, but this time string actually replaced the T placeholder. Okay, and list.add, list2.add hello, list2.add world. Similarly, and the third instance of the generic list class, I have passed on an example class, which is nothing but this class. Okay, so I have created a new instance of the generic list class, and to this instance list3, I have added the new example class. Okay, so next is generic classes are the, okay, before that, what I can do, I can show this in action, this code. That will be great, I think. Okay, so this is the code that we have seen in that last slide, and if you run this code, Control F5. So here you go. Parameter type is system.int32. that is 1 and 2, that is of type int, value is 1, value is 2. Similarly, you have got system.string, value is hello, and system.string value is world. And the third time when you are passing a class, it gets you that value as generic classes, which is the namespace dot test generic list dot plus example class. Okay. So getting back to the slideshow, if you look into the next slide, which you have started. Anyway, generic classes are the preferred way of creating collection. So they are the type safe. They are type safe and have better overall performance than their non-generic counterparts. Remember, if you have gone through the last section on non-generic, array list section, as well as the hash table, or any one of these sections would have given you an insight that these non-generic classes which use system.collections namespace, they are not type safe because they can take any time. They can take a mix data type. On the same instance, you can add an integer or a string or a combination of both. So they are not type safe. Okay. So these generic classes we'll soon see with lots of examples that they are better overall performance wise than their non-generic counterparts. So generic types should be used to maximize code reuse. That is one point I would like to stress again and again, and we'll see them in action. However, we need to study non-generic classes to maintain legacy applications. So they have got much like the legacy values to maintain a legacy application in an organization. You can create your own generic interfaces, classes, methods, events, and delegates. Generic classes may be constrained to be used on particular data type. An example code is in the next slide. Okay, and this increases the number of allowable operations and method calls to those supported by constraining type. We'll see about what is the constraining type. Okay, now constraint by value type. Before we go for the that code demo, which I will also show you on the Visual Studio, a bit of theory, little bit. So what about the constraint by value type? Now you can constrain a generic type to a value type by setting the constraint of the type as follows. So class constraint by value, if you name a class and pass a t input parameter of any type where t should be struct. Now the struct keyword is used to constrain t to a value type. The object can then be instantiated like new constraint by value type, an new instance, and you can make it as double and you can specify any value type you want. Okay, constraint to allow only reference type. So what are reference type? Like any class is a reference type. So it is passed by reference, you can say, as opposed to a value type. So if you are not sure about what the value type and reference type, it is sufficient to say that for value type, a copy of the data type is passed into the function, but the real value, real copy is still left intact. But for a reference type, the actual the reference to the class or anything that is of reference type, any data type that is of reference type is passed, so that if you change the value in the called method, that remains changed in the original copy also. Okay, so that's another concept. Don't worry about that if you don't understand. So you can also constrain the type to allow only reference types. Similar to how you do it for value types, you'd use the class keyword to constrain the type to a reference types, like this one. By reference type t, where t should be a class, right? Now interface type constraints, similarly you have got interface type constraints. So you can constrain the generic type by interface, thereby allowing only, because what is this constraint? Constraint is basically it's putting a where clause, like in the basic form. I mean it filters a class with these constraints. These are constraints applied for this. So there is a bunch of interface and classes. So interface iShape and a class square that implements iShape, and there is another interface i4-sided square that implements iShape, and a class rectangle that implements I4-sided shape, and a class small rectangle that derives from the class rectangle. All right. So now here, when I say that this class constrained by interface T, where T is nothing but it should implement, this means that it should implement or it should derive from this interface, I4-sided shape. The type T is constrained to the I4-sided shape interface, which allows only classes that implements. Please look at this, hear this word again and again. Only classes that implements this interfaces, or the classes that inherit from a class that implements this interface, okay? Or any other class which actually is derived from constrained by interface, being the base class, to access the generic type. Even if the I4-sided shape inherits from I-shape interface, you can't use square as the type for T. You can use only rectangle or small rectangle, because this is directly implementing the I4-sided shape. Okay. Because rectangle, so small rectangle is actually deriving from the rectangle class, and rectangle is implementing I4-sided. So small rectangle, you can use small rectangle or a small rectangle, because they are directly or indirectly implementing I4-sided shape, but you cannot use square as a type of T, because it is not implementing I4-sided shape. Now we can use these constraints together as below. Okay, so there is a code which I will now show you on the Visual Studio. Okay, so before I move further, let's show this. So this is test constraint class. Now the thing is, let me actually make this as a startup object on the properties page. So this is test constraint. Okay, so test constraints, this is the startup object now. So if I run this code, it will just tested the constraints. Okay, and then I will explain a bit. All right, so it shows just is tested the constraints. Now what happens is that, I have intentionally commented out this line, because if I put this line, you can see straight away that there is a squiggly line. It's a compile time error it gives. So it says that test constraints.small rectangle must be a non-abstract type with a public parameterless constructor in order to use it as a parameter T in the process, in the generic type or method. Okay, because what this constraint, look at this. This constraint is class constraints by combination T, where T should implement iRectangle interface. What is iRectangle? iRectangle is an interface, and also it should have new with an empty pair of circular brace, means that it should have a public constructor that is parameterless. Okay, so big rectangle is actually following this constraint, because what is big rectangle? Big rectangle is nothing but it is deriving from, or it is implementing the iRectangle interface, and big rectangle does have nothing inside. That implicitly means that it has got a public constructor by default, which is parameterless. However, look at this small rectangle. So this small rectangle has got a public constructor which takes in an argument. It is not parameterless. So once, as per C# concepts, fundamentals, if you put a public constructor which is something else, but it's not a parameterless public constructor, then this public constructor, which is supposed to be the default if no other constructors are defined, that is overridden. Okay, so if you wish to still have a public constructor that is parameterless, you have to explicitly write it, but here it is not there. So this is not satisfying the condition of this constraint. Okay, so next is, in the previous slide, we are constraining T to use iRectangle interface and must have a parameterless public constructor. Okay, so what I have already told, it's already there in this slide. So now, when to use generic collections? Now, using generic classes is usually recommended, okay, as we gain the immediate benefit of type safety. We don't have to derive from a base collection class for using the generic collections such as list T, on which we will be soon coming in the next tutorial, and implement type specific members for achieving type safety. So we don't need to derive from a base collection class and implement type specific members, but we just have a ready-made generic class ready for us, which is type safe. So generic collection types perform better than the corresponding non-generic collection types, because with generics there is no need to box the elements because they are only allowing one type. Finally, to recap, the most common use of generics, as we have seen, is to create collection classes known as generic collection classes. And the generic collection classes use system.collections.generic namespace in Visual Studio. And type parameters T in generics make it possible to design classes and methods that defer the specification of one or more types until they are declared and instantiated by the client code. By using a generic type parameter T, we can write a single class that other client code can use. Now, the generic classes are type safe and have better overall performance than their non-generic counterparts. Generic types should be used to maximize code reuse. Generic classes are the preferred way to create and manage collections, and the generic classes may be constrained. We have seen a practical example on Visual Studio to be used on particular data types or with specific conditions. Generic collection types also perform better than the corresponding non-generic collections, because with generics there is no need to box the elements. That's about it.